Hello, everyone. Welcome to the February community meeting for the AWX community. This week we have a couple exciting topics. Let's get started. So let me share the agenda right quick. So first up on the agenda will be Seth Foster's Seth Foster's demo on one new exciting feature that will come out in today's release of AWX. It's the new Mesh Ingress feature. So I'm gonna, unfortunately, Seth is not going to, not able to be here. He's not here today. So I'm just gonna play the recording of his demo. All right.
All right. Hey, everybody. Welcome to the AWX Community Meeting. Today, I wanted to talk about Mesh Ingress. If at any point you have questions, just raise your hand and we can pause the recording, and there should be people on the call who can answer questions as I move along and explain what the Mesh Ingress feature does. So what is Mesh Ingress? Well, first, I think it's helpful to step back and look at what deploying a remote execution node looks like without using Mesh Ingress. Essentially, what you have is we have a control plane node that can peer out to remote execution nodes or hop nodes. One downside to that is at least one or more of those nodes will need to have a listener port defined and will need to be in a network environment that allows incoming connections, inbound connections. But let's say you're in a data center that doesn't allow inbound connections from your control plane. This sort of topology will be tricky to set up if possible at all. So this is why we developed the Mesh Ingress, which will allow remote execution nodes or hop nodes to be able to connect inbound to the control plane. So here's a view of what this looks like. When you instantiate a Mesh Ingress object, it creates three main things. It creates a pod that runs inside of the cluster, and this is essentially just a receptor hop node. This is the same thing as setting up a hop node outside of the cluster, except this one is inside the cluster and it's registered to the database automatically through the operator. It also creates a service that we can use to route to the listener that's on this hop node, and it creates a route. So what happens is remote execution nodes or hop nodes can use this route URL to gain access and to connect to the control plane task pods. Because as you can see, the task pods are also connected to this same service that is pointing to the WebSocket listener on the hop node. So this is how we're going to achieve allowing remote execution nodes to connect inbound to the control plane. So let's take a look and see what that looks like in practice. So I have an instance set up on OpenShift. As you can see, there's just one task pod, one control node. It's in a ready state. But what we can do is deploy a Mesh Ingress node, I'll call it. So to do that, you can create a YAML file. I created a YAML file called oc meshingress.yaml. And the contents are, you need a kind, which is the AWX Mesh Ingress. This is a new kind, a custom resource definition that we've created specifically for this feature. And you need to provide a unique name for this resource, and you need to provide the deployment name. The deployment name is the name that you gave your AWX deployment in your AWX spec file. So, for example, you can run oc get AWX to get that name. So this is what you would use as deployment name. So once you have that YAML file, it's just, you simply apply it to your cluster. And now the operator will take that YAML file and start running playbooks for the roles associated with that new AWX Mesh Ingress resource, and we'll start creating Kubernetes objects, the service, the route if you're on OpenShift, and the pod itself. But what we can see is shortly after, we should be able to refresh this page here, and we'll see a hop node that has been registered to AWX automatically. So it's called Mesh Ingress 1 because that's what we called it in the YAML file. And you can see that the node type is hop. Now what we can do is start connecting execution nodes to that hop node. So let's go ahead and add a execution node. And what we'll do is we'll use Amazon EC2 to create us an instance. So I'm going to go here and call it SBF machine. We'll use Red Hat. And let me provide some information here. We're not going to allow any incoming traffic over the internet other than SSH. I'm only going to allow SSH connections from my local laptop so that I can run the install playbook. So this is essentially a disconnected node. It doesn't allow inbound traffic. But that's okay because we're going to connect inbound to the control plane to form the mesh. So let's go ahead and launch this. Okay, so once this is created, we should be able to grab our URL here and add it as a new execution node in AWX. I'm going to hit save. Now you'll go to the peers tab. When we hit associate, we should be able to see our mesh ingress point. You can see that the address here is mesh ingress 1 sbf-devel. So this URL is what was created when the operator created a route. So this is essentially the address to the route that is then going to point to the service inside the Kubernetes cluster, which points to the backend listener on the hop node. So you can see on the right side, it says WS, that means WebSocket connection on this port 443. So let's go ahead and link that up. And before doing anything else, I'm just going to look at the topology view to make sure this looks correct. So we have an execution node pointing to our hop node, and we have our control node automatically connected to that ingress hop node. So now what we do is we need to run the install bundle for this execution node. So go to the execution node that we just created. We'll hit install bundle. I'm going to save it to my downloads folder. Untar it. I'm going to go into this folder here, open up a new terminal. I'll bump up the text so that you can see. And now we're going to type Ansible-playbook. I need to give it an Ansible user that can SSH to that EC2 instance. By default, EC2 uses EC2-user. And then I give it the inventory file, and then we run the install receptor. So I'm going to let this run. Essentially what we're doing is we're running the install bundle against that EC2 instance. And what this does is it installs pretty much all the packages necessary that will allow us to run jobs on that execution node. That includes things like Podman, Ansible Runner, Receptor, and it will configure all of those things so that after this runs, we'll have a execution node that should be in a ready state that we can run jobs against. So I'm going to let this run, and then whenever it's finished, we'll come back to AWX. Okay, so now that that playbook has ran, within like a minute or two on AWX, you should see that execution node go into a ready state after it completes a periodically scheduled health check. So now we should be able to run jobs with this execution node. And to do that, I'm going to go to instance groups. We'll add a new instance group called execution nodes, and we'll add the instance to it. Now what we'll do is we'll go to our demo job template, go to edit, go to instance groups, add execution nodes, save, and launch. So this launches the demo job on the newly created execution node, and you can see that it's successful. Let's reload the output. We see the output here, so there you have it. That is running a job using the Mesh Ingress feature on a remote execution node. There's a few other things I want to show. So let's say you wanted to, for example, delete the Mesh Ingress node. You can't do it through the UI or the API. There's no way to checkbox this and remove. Instead, this is a Kubernetes instance or resource. So what you can do is OC delete AWX Mesh Ingress and then give it the name of that instance, Mesh Ingress 1, that's what we called it. So when you delete this, it should also deprovision that node from the instances page. So if we go ahead and refresh here, we should see that it's no longer there. Another couple of things to note is you can have multiple Mesh Ingress instances going at the same time. So let's go ahead and apply that one back. So that's going to create Mesh Ingress 1. Let's go edit that YAML file. And let's also create a second one. So I'm giving it a unique name here, and let's apply that. So now we've created a second one. And we should see that in the topology view shortly, once the operator gets around to spinning that one up. And one of the reasons why you might want multiple ingress points is that any sort of remote nodes that you have connected to the mesh, if it's all the traffic is flowing through one particular node, if that pod were to go down or crash or get into some sort of instability state, then you still want traffic to be able to route through another node. So it might be good practice to have some redundancy set up in the mesh. So you can see that the execution nodes, since we deleted those nodes, are no longer linked to them. But you can see that the control plane node does automatically connect and link to those newly created ingress nodes. So if I wanted to peer these up, I would simply go back to the execution node, go to peers, associate, and then checkbox those two. And now we have the execution node peered to the control plane through these two separate points. And of course, anytime you make changes with peering on remote nodes, you have to rerun the install bundle. So I would rerun the install bundle. It would push a new receptor config file to the execution node, and we would have proper connections set up. One last thing I want to mention is, or to take a look at, is what services and routes get created whenever you create these objects. So let's do a OC get all and take a look at what gets created. So if you remember back in the picture, I said it creates mainly three things: a pod, which is that hop node, a service, and a route. So we should be able to see that in the details view of this Kubernetes or OpenShift get all command. So we can see that it created, since I have two of these ingress points running, I see two distinct pods. It's those two here. I should see two services. I see these two services here. So each one of these mesh ingress has its own service. And I should see routes. So it's hard to read here, but here's the first route to Mesh Ingress 1, and here's the second route to Mesh Ingress 2. So those are the main resources. If you want more details about how these resources are created, you can look at the source code for the AWX operator, which explains how we're configuring and setting up these Kubernetes resources. But there you have it. That's Mesh Ingress. It should be in version 23.a.0, so upgrade your systems to have this and go ahead and deploy Mesh Ingress and let us know how it works out for you. Thank you.
All right, thank you very much, Seth. I'm going to stop sharing. Okay, so there's a couple questions from the from the chat. So is hopnode par HA? And if there's job running and hopnode restart, does the job still runs or does it fail? Right. So let's say if the let's say if there's some disruption due to no outages, right? And the worker node that's hosting the Mesh Ingress hopnode failed, Kubernetes should reschedule that pod to another container, and we should be able to tolerate like small disruption in communication with hopnode, even with a single hopnode. And I think this is one of the things that we have tested, just simulated by manually deleting the Mesh Ingress hopnode pod. And as Seth mentioned earlier, for like a more robust HA setup, you can set up multiple mesh ingresses and have the remote execution node peer to both of the mesh ingress. And assuming that you have the mesh ingress pods split out to different worker nodes, it will provide you with a little bit more redundancy. Now, Cha, does that answer your question? All right. And what Ceph demo is running on OpenShift, right? On OpenShift, there is no additional configuration needed. It's just deployment name, like specify the deployment name for AWX, and we will automatically create a route and configure the route and configure the nodes, configure the instance within AWX correctly. Now, for non-OpenShift Kubernetes, we have left in plenty of configurability in the AWX Mesh Ingress resource for you to be able to stand up your own ingress and then supply the host name for configuring the node within AWX. So, sorry, configure the instance within AWX. And also, our wonderful community contributor, Kira Kobo, added support for traffic. It's another ingress controller. So if there's any specific use cases, please let us know. The documentation for how to use AWS Mesh Ingress is on the way. A lot of section when this first land, a lot of section will still say under construction. Try it out in your specific environment. See if all the configurability that we put in so far works for your specific situation, and please let us know if it doesn't. All right. I'm going to pause here for a second before we move on to the next topic. Is there any other questions? Chad?
I'm good.
All right. Looks good? Okay. Let's move on to the second topic. The second topic is a saga that we have been going about around this particular error message. So, and here is the GitHub issue that sparked the investigation. So basically, when the job event comes back, we shove it through Ansible runner process, and when if there's anything that's non-JSON that got passed to Ansible runner, we end up with this generic message. Well, for this one, it's specifically like unexpected EOF, right? So this is a very, very generic message, and unfortunately, this happens for many different reasons. So, first thing first, if you run into this, if you run into this error message, in any of your job failures, please come help us in this issue by supplying your own specific case here. And this, after a couple of very investigations, we zoomed in onto another field on the API called result traceback, right? When we receive something like this, there's typically a result traceback that's associated with it. And I think I wrote a summary somewhere down here around the different variations. All right. There we go. So, and thanks to the help from the community, we were able to trace down a couple of cases. So we found a bug within receptor that override the failure status. So even though the job had failed, we falsely put a finished in the result traceback, causing the actual error that we got from receptor to be muted. So like, for example, one of the cases that we dug into is a Kube API server is struggling at that time, so we're not able to like establish the log string connection with the Kube API server. But we ended up with this error in combination with this useless result traceback. So we fixed that, and this is in the latest AWX latest receptor release 1.4.4, which was 5 days ago, and this is in the latest AWX EE container. So please flip your AWX EE on the control plane to pull the new image by temporarily switching the deployment image pull policy to always. That should get you guys pull down the new AWX EE with the new fixed receptor. And there's a couple more bugs that we found. Parse status std_out EOF. This actually happened on successful cases. So we have difficulty determining whether receptor itself have difficulty determining whether the EOF that it received is the actual end of the job execution, because receptor is not aware of any Ansible bits. It's just the transport mechanism in the middle. So the best assumption that we made is, okay, if we try to read the log 5 times and we receive the same EOF and we do not see any new messages, then that's actually good, because we probably reached the true EOF. Therefore, we should finish. We found a bug that from one of the previous refactor, causing that happy path to be marked as an error. So it introduced a race condition where if controller haven't finished processing the true end of playbook message before we finish the retry, we will erroneously mark the job as failed with this, again, very generic failure message. So hopefully that problem doesn't happen. And also we found another bug that's caused by one of the previous refactoring that causes us to, here, I can open this one. Well, this particular bug caused us to not actually resuming the log from the last observed time and reinitializing, reread the log string from the beginning of time, which makes us having to reprocess all of the message for a disconnection. So it causes the reconnect to be very expensive just because we are fetching way too many log message that happen way before the disconnection event. So that's fixed. So again, thank you very much for everyone in the community that contributed their specific failure cases. And if you still see this error with one of the result traceback that's not covered here, please provide the information in this issue, and we will look into it. So yeah, in summary, please, also another change that's happening in Receptor is this Receptor support reconnect will be enabled by default from now on, since we no longer support any Kubernetes version that does not have the fix that allow us to do the reconnect with the timestamp. And yeah, I'm going to pause here for a second. Is there any questions? Anyone run into this problem? Okay, awesome. Moving on to the next topic. Christian Adam.
Hey, sorry I didn't get to add it to the agenda, but there's these 2 PRs for this really interesting idea that I think could help us out going forward. So the kind of setup for it is over time, you know, the AWX CRD has grown in size a lot. There's a lot of different parameters that get added for often like very specific scenarios or use cases, and they've gotten pretty granular. And so one solution that we've found for keeping the CRD from just, you know, snowflaking and have like, or what do we call it, snowballing and having a ton of parameters is to have an overrides parameter that allows you to basically override large chunks of the of different deployments. So yes, we're trying to fix a parameter problem with a new parameter. I get that is sounds backwards at the beginning, but yeah. So the idea and how we'll go into more detail here, but the idea is that you'd have a override section, and then you would drop the YAML that you want applied on the one parameter to rule them all exactly. You'd have that YAML applied in a designated section of the deployment that override is for. And there are currently 2 implementations out there right now. How put up a PR, and then Kurokobo put up an alternate PR. So we're gonna review and look at those and try and evaluate the best path forward. But the biggest thing that we want is some people to try these out and see, you know, if they cover use cases that you might want. The use case that got us thinking about this was wanting a user, I forget the name, wanted to have a sidecar container. And we could add a parameter for a sidecar container, or we could enable people to add in their own section on the deployment for a sidecar container. So, is this which one's this? There's 3?
No.
I see.
Right,
Yeah, this is the sidecar. Yeah. Mm-hmm.
Yeah. So this is the original issue that kind of prompted us to go down this path. Like, just adding this particular PR adds you know, extra sidecars, and then you got to think, okay, is it on the web container? Is it on the task container? Is it on the Redis container? Is it sorry, Redis is the sidecar already. Is it on the Postgres container? Which on which container do you want a sidecar, right? So that snowballs into a couple extra parameters too. So yeah. And then I think there's a couple other cases here.
Yeah, I think there's like 3 or 4 other PRs that are open that that would be resolved by this. Yep, there's one. There's another.
Yeah, like DNS config for the different containers. So, and like host network and DNS config for specific containers, right? So that's a lot of parameters to add, and yeah, it's getting pretty big. Like the AWX CRD is getting pretty big.
And to be fair, I don't think that most users will need to change those. So I think for these kind of really niche use cases, I think that the overrides section would be really great.
All right. Yeah, and the deployment template is getting too long for my eyes. It's hurting. So
The one other thing, just to mention it while we're talking about it, is that there is a limit to how big the CRD can get. I think we're not near that limit yet, but it's good to be mindful of that. It's 1 megabyte. Well, 1 megabyte with all of the CRDs and bundle metadata and all that. Everything when you run make bundle. If that bundle's over 1 megabyte, then bad news bears.
So we can go into a little bit about about the two different implementation, right? So my specific implementation is based on customize. As I was thinking, like, okay, we essentially trying to customize here. Let's just use the tool that people use, like familiar with, to customize, right? And so I added a customized binary to the image, and then the code is pretty simple here. It's essentially just copying the template files, template out the files, drop it into a directory, and then invoke customize build, and then deploy. So that's pretty simple, and the same pattern can be replicated to to any other resources that we have, right? So that's that. And customize is really flexible. But so please take a look. I know the description and other stuff doesn't say much. It needs a little bit of learning about how customize works in order to use this correctly. But if you have a specific case that this might work, please try it out. Help us validate the idea. Now, Kirakobo put he is amazing community contributor, by the way. Kirakobo put up another implementation, and this one is more Kubernetes specific. Sorry, Ansible specific. Rather than pulling in customize, he's using
Is a merge by, right?
yeah, merge by.
Yeah, lists merge by. Yeah, so I mean, this might be a better user experience because like the difference would be you'd be putting in like the actual YAML that should show up on the deployment, right? Whereas with your PR how it's the customized logic, which people might not be as familiar with.
Correct.
So yeah, I think we should evaluate both and see, because there might be some pitfalls to this one that we haven't seen yet.
So we will keep these two PR up to date with Deval, and we should have doc for how to build a custom AWX operator image with the change. It's just make Docker build, Docker push, and then deploy, right? But it should be in the documentation. If that's missing, please let us know too. Please try out these two PR and see if these two PR works for your specific use case, and we can decide which way do we go forward with once we have some reviews on this PR. All right. Thank you very much, Christian, for bringing up the topic. Next up, Alan, do you have time to talk about some of the new exciting changes coming to RBAC?
Sure. So I've got something running, so I can bring it up to kind of show while I talk about it really quick here.
Sweet.
Okay, so talking about AWX, this is definitely like an impacting change, for people using it. So here I've got the UI up, and this is from the job template. So I had a client that I'm running through like data creators, and this is with my current branch right now. And to tell you what my branch does is that it pulls in this this branch from this library. We already have this library. Let me go ahead and link it here. This is Django Ansible base, and it's public. It's upstream, just like AWX, and it already has different stuff in it. It has what it calls apps, so it already has these apps. So it's like one project where we're putting a lot of stuff that's like standardization of practices that cross like beyond just AWX for other people, but it's also like generally like it's just a library. So it's like Django app, like there's instructions for how you can use it. This provides Django apps, which is like a little bit more than just like a Python library. Like if you have a Django project, you could go add these apps to your project, and these are specific apps. So like this folder, there's like an authentication app. So anyway, this is totally upstream, so it's like totally in the clear. This is like Red Hat, we're doing stuff open source, and you could go use one of these if it were useful to your own project. And I call that out because when I've been doing this, so this is obviously this is a monster here. I'm not, this is a very large piece of code. But the function of it is that it provides a Django app that does that provides a functionality that pretty much overlaps with what we're doing in AWX now. So we worked with like this. AWX has had this role system for a long, long time. It's been incredibly stable. In fact, incredibly static for a very long time. And I know that, like, that's what I know. So I was coming from that. Coming from the AWX system is how I wrote this. And I could tell you a lot about the specific details, like whenever we do query sets, we show anybody any list of any permissioned resource. We have to use query sets that keys off of this, keys off of joins with this key table, which is the role ancestor entries. So you have roles, and then the roles have parents, and then it combines them up through the ancestors. And then the ancestors, how you do all queries. So that's the key design principle, and actually keeping a table that's functionally the same as that and indexed the same was like it's like a non-starter if I can't do that. So that was the first thing that I was doing with this. And I have this running with AWX just as it is. And you can click through and like see things and do things in the UI because the API of this right now is written to be backward compatible. There might be a few like wonky things, and access list is actually the hardest part of it all to get all the access presentations. But you can see like there's a user has access to this type of access via this team role or this user role. So a team has a role or a user has a role, because I think that people kind of intuitively know how roles work in the system. And again, this is working because it's putting in that library, but then putting a translation layer in for it to be backward compatible. So I'm looking at a job template right now, and you see how a job template works, and you see how what I call the object roles work. So I call the AWX system an object role system. Whenever you make a job template, it automatically creates all three of these roles. And that's not like too much, but then you get to the organization level, and then if you look at a organization, like what roles can you add for that? It's a lot more. And organization roles, I think, are one of the most useful things out there. But then there's like a lot of design elements that I didn't like, and but it's obviously useful. It's it's been out there and used so much. And a part of the problem is that if you look at these like organization rules, they are so useful, but it's like we need to add even more to get even more use out of it. But then it becomes intractable. Like we auto create all of these every time you make an organization. That's just not going to fly to like continue adding more and more things into it. So with the new library itself, the scope changed over time, but here, let me make it a little bit bigger. For the new library, at first it wasn't API, but then it started to provide API endpoints. So these last 3 API endpoints are the new ones. And the proposal is, in fact, that you have roles as they are, roles are deprecated. So there's the old roles and the new roles, and I'm sorry it's basically like that, but that's just how it is. You can't, you're doing something like from the ground up. This is really ground up work. You can't just take the old models and then like transform them into the new ones. So this is an endpoint from the new system, and you can see that this corresponds to the definition of a role. It is not an object role itself. So if you look at this page, what I call role definitions, you're not at the object role level. Instead, you're at like just the general formatting of what a role is. So one of these is the organization admin role, and you'll see it when you get to it. Yeah, it's got a really long list, right? It's pretty much everything. The organization admin role is going to contain effectively all of the permissions in the system. And the beauty of this is that you could take all this content, copy that whole entry and then go and then put it in here and then make your own new custom role. And you can pick and choose what particular permissions you want to put in it. And so you can remove a particular permission, I don't know, for whatever reason. And then, you can get into, here's the options. And in this, like I enumerate the permissions. So these are just details about it. So that's like the organization admin role there is not a specific organization admin role. That's an object role. It's the idea of the organization admin role, which would then become applied to an organization. And then these are assignments. So I have a role definition from the prior page and I give it to a user and I give it for a particular object. So those are the 3 things that go in there. I actually copied the 3 things from the Ansible, from the pulp model. So pulp is used by other Ansible things. So that's copied from it, but don't be fooled. Under the hood, it's all object roles. And I want to call out for this system, the two features I can easily articulate right now. If you want to go into it, look at the add permissions. So you have organization admin role. I think the main use of this for like a new feature, because this is truly new functionality, is that you could take the organization admin role. And like I said, you could copy it and then modify it and then just keep all the add permissions and none of these other permissions here. Because as we have like project admin role, that lets you do 2 things. It lets you create a project, but also edit all projects that are in the system. If you just give somebody the add permission for a project, which is right here, then they can make their own project. And then they'll get auto-assigned an object role for that project, and they can edit the project. And for me, I think that's huge. That's like the number one useful feature you can get from this. There's also separated delete permissions. I don't think that's useful. Like, why would you want to just be able to delete something? But that's up to the user. So then we stop trying to make decisions and we like kind of put it more in the user space. So there's a lot of problems that we have that are addressed by this business logic. If somebody says, oh, this user should be able to do this persona should not be able to do this. And those are often addressed by adding more logic, which is the wrong way to do it. It's much better if you can add a particular action that's tracked in these permissions. So then basically you defer it so it goes over to the user themselves so that they can create a custom like a custom role type, role definition here that lists those specific things that they want to be able to do. So it's like more they can be doled out more specifically. And some of the things I have in mind, I'm not doing yet, but if we go this direction, it's certainly we would want to do is like you'd have a permission to cancel jobs is one thing that's come up. The ability to view jobs, I think, is more important. That needs a little bit more thinking about. But like if you're an organization or you want to be able to like just give somebody the ability to like see all of the jobs in the organization or something, like various breakdowns of what we have is like the auditor role, for instance. I think those would be very, very useful, and we can kind of get rid of like the things that we do under the hood without telling the user. So that's a very big thing. I don't know when it would I don't know when it would actually come out. There are a couple of things still blocking me from really saying like we should go ahead and move with this right now because of the backward API compatibility. We want to keep around for as little time as possible. So we want to have like a good strategy for the API versioning cycling. And then also due to other needs, like system roles come up a lot, and I think that we need to have a good plan for system roles. I already know how I want it to happen internally, but I don't really have a good API. The API is not fully fleshed out for it. So that's my status. It's a huge change, huge feature. It's really the internals of the access control system. Just swapping it all out.
So if I were to write out like a one-line description for this feature, right, which I'm gonna try to do in the description of the video and in the community meeting agenda. So this allows us to define custom roles, right?
Yeah.
Custom as you want.
Because I keep referring to permissions, but that's the point of custom roles. Because custom roles enumerate permissions.
Right.
Yep.
This is something that the communities like. We have so many different RFE for. Hey, can you create a role that does this specific set of permission versus that specific set of permission, and we just cannot add them all, like by default. So this is introducing the well-needed flexibility.
And Christian made in chat, he's saying like maybe this is be like a version change, like API from V2 to V3, and I see that point. You're probably right. That would make the most sense, especially because the roles are very embedded in the other serializers. They're not just like on their own. So that's actually a big takeaway I had from this. From the library's perspective, because if you have a Django project, you could go use this library, use the same roles library for your own access control. But I tried to make it with the philosophy of outside looking in. So right now I'm trying to keep on the side of like having, here's the roles endpoints and then the rest of your apps endpoints over here. And then we can add some linkage between them, but I don't want to have them as like mixed up, intertwined is what we have in the current system, because that makes it, so I've learned that makes it harder to remove.
All right. Any other questions for this particular topic? All right, cool. Christian,
Actually,
yes.
yeah, question. When can users get some eyes on this? Is this merged already? Is it in a release?
They're both still pull request, but I'm starting to work some channels to get people to review the Django Ansible base library itself. So I hope that relatively near term, like pretty soon, I really do want to see that merge. So then you could hypothetically use it as a library. I don't know if it's beyond PyPI yet, but soon enough. Yeah, David?
Yeah, so you were talking about like, because it is a fundamental like change, and you're talking about like API changes and stuff, and you're trying to make it somewhat backwards compatible. Is this, in theory, though, would this kind of mess up potentially modules that
it is backwards compatible? Like
it is?
Because the fundamentals are compatible enough. Now, I've got a lot of problems around the edges. And there's a couple of things. There's just one or two things that I could note that we just fundamentally can't support. like the auditor role inherits via certain relationships, and we can't do that because it's a little bit more strict about what relationships are possible for parent-child resources. But those are, I think, really minor in the grand scheme of things. I don't think there's going to be any problems with that. But the current roles API, like you can go there and you can interact with it by the same contract. So the current collection would still continue to work, but that triggers a whole process of deprecation cycle, right?
Mhm.
That we
Okay.
want to have it work with all the new stuff. So it would be gradual, but you want to get rid of the old API just to get rid of the old API. There's like performance costs and other things with it.
Okay.
Alan, I'm trying to hunt down the PR you have for AWX.
Well, I linked it in the chat, the Django Ansible base, and that'll link to the AWX one somewhere.
somewhere.
I'll go put it in the top.
Thank you very much. Also, this is a huge feature. All right, I'm gonna stop the recording here. Thank you everyone for coming to hang out with us.